Okay, let's take a look at Section 29D. And in Section 29D, we talk about the mean and the standard deviation of a discrete random variable. So notice, remember when we talked about statistics, we also mentioned that whenever we refer to the standard deviation is always related to the mean. So if we want to talk about the standard deviation, which shows how spread out the information is, or how spread out the probability distribution is, we want to go ahead and first determine what the mean is. Now, the great thing about this is that we already know what the mean is. The mean value of a discrete random variable is its expectation, because that's what you would expect. So what we can do then is, say for example, here again is our 2 coin example. If we wanted to find the mean, which is also going to be equal to the expectation, I can use that formula that we had where I just take the value of little h, which is the result of the values of the discrete random variable, and multiply it to its associated probabilities. So we said that this was going to be 0 times it by 4/9. I think I wrote it 4/9 times 0 the other time. 4/9 times by 0 plus 4/9 times by 1 plus 1/9 times by 2. And we said before that this was going to be equal to 2/3. So your expectation for any discrete random variable is also going to be considered the mean value of the probability distributions. Okay, so now that we know what the mean is, how do we go ahead and determine what the standard deviation is? Because remember we said that it is not sufficient to only talk about the measures of central tendency. You also need to go ahead and talk about the measure of spread, which is the standard deviation. So how do we calculate this? Now, we had a very, very long process of actually doing this, but there's a very simple way that you can calculate this. Now, if we have our 2 coins and if we have our probability table, probability distribution table, what we need to find out as well is we need to also go ahead and find out what this h squared is. So if I take h squared, well, 0 squared is just 0, 1 squared is just going to be 1, 2 squared is going to be equal to 4. Okay, and this is how you calculate it. The standard deviation squared. Remember that we said that this symbol here represents the standard deviation. If we square it, again what we're talking about now is the variance, this is actually going to be equal to the expectation of x squared minus the expectation of x quantity squared. Okay, now don't get these two mixed up, because these two right over here represent 2 very different things. Now, if we go ahead and take a look at how to calculate the standard deviation for this particular example here, we already know that the expectation is 2/3. So I can go ahead and substitute the 2/3 here and square it. Now the question becomes is, how do you find the expectation of x squared? Well, here, oh sorry, h, let's use h in this case because we're talking about h. Sorry. Okay, how do we go about finding the expectation of h squared? Well, the expectation of h squared is instead, you're going to calculate it exactly the same way that we had here, except for instead of using these values of h, you're going to use the values of h squared. Okay, so let's go ahead and take a look at what we would use, or how we would actually calculate this. Well, you're going to take the same thing. You're going to take the associated probability, which is 4/9 in this case, times it by the value of h squared that's associated with those probabilities, which is still 0, plus, we're going to take 4/9 times it by 1, because that's, of course, the associated h squared value, plus 1/9 times it by the associated value for h squared, which is going to be 4 in this case. So notice it's different. So what we come out with then is going to be 4/9 plus 4/9, and this of course is going to be equal to 8/9. So that value right over there, this value here is the expectation of h squared. So now, what we can do now is we can calculate what the standard deviation is. The standard deviation squared of a variance is actually going to be equal to 8/9 minus the 2/3 squared, which is going to be 4/9. So therefore, the standard deviation squared of the variance is going to be 4/9. So that means that if we take the square root of both sides now, we come out with the standard deviation being equal to 2/3. So in this case, this is just by coincidence, but the mean value is going to be 2/3, and the standard deviation is going to be 2/3 as well. And that's how you calculate the mean value for a discrete random variable by using expectation. And that is also how you go ahead and calculate the standard deviation of a discrete random variable using this formula here.